来录一下。好，这个我们这里录一下啊。你看，我们之所以做 factoring，就是为了不要最后试数的时候试到上面去。为什么？这个之前我们讲过，叫做 sign diagram。因为你总
嗯
看符号，你看你后面都看的是符号，对不对？
嗯
你总看符号啊，你把负四只能带到下面这个地方啊，你带回去就没有意义了，那还要算半天吗？你带到下面，负4减7肯定是负的嘛，负4加3还是负的嘛，负负值得正，你是大于零的。
哦，
再到这个地方，这就是我们说为什么要做 sign diagram，这是最容易的地方，好吧？
好的，
这样子，你带回去是最费劲儿的。7以上也是，你不就是带个8？那很明显8减7正的嘛，8加3正的嘛，正还是得正嘛？所以说
对，
明只能取中间，而不是取两边。
好的，
第二就是图像法，图像法一定要会，两个 factors 就说明两个 solution，一个是7，一个是负3。然后因为前面是正的嘛，它是正1，对吧？说明 a 大于1是开口向上，对不对？你一画完之后，因为要小于等于零，你要取下半部分，很明显3到7之间，对不对？你看。只有这一块是小于零嘛，它是在 x 轴的下面，所以
嗯，
刚好对应到 x 上呢是从负3到7，你觉得有没有疑问？
我有
就大于取两边，小于取中间，对吧？这种应该以后不能再错了啊。
的，
嗯，这么这次还可以吧？是不是这样做啊？
嗯
哎，
嗯，
那 Emily，你再看你第二题啊，简直是，
呀，
呃，人家是 t，你首先你把它变成 x 了
我错了，
啊，而且题也抄错了，人家是 t squared，你抄个 t cubed。
我的又错了，
对，这都是这不应该，好吧？但是你答案最后做对了。这会留
好的，
下大于取两边了，看到没有？
嗯，
嗯，对，然后底下是到4，哎，这个怎么写 interval notation 呢？也会写 interval notation 啊。
那个
前面
f 嘛
嗯
，interval notation
怎么写？小于4怎么写？
小于4，无穷到4
对，然后呢？
，u
对，然后呢
4的无穷
？Yeah，以后就写成这样，好吧？
大，
这些你也是啊，都写成
嗯
这样啊，要练啊，练多
嗯，
了就慢慢就一下就会了。我看底下21，哎，21你就写了哈。以后你都写，好吧？你就是保持 consistency。
嗯，
嗯，然后236，36，
下来做奇奇怪怪，
对，36我们就是这样做的，这就是我们说的图像法嘛，找到 roots 做图像嘛，
嗯
对吧？图像是这里前面的 a 还是正的，对吧？依旧是这样，小于取中间，看到没有？你
嗯
看这小于零嘛，取中间，看到吧？这两
嗯，
个 root 中间，这是非常好的，就是这么做，OK？这次你看没有问题吧？对，
嗯，
对，小于
我
取中间，
那个不太会，
其他的没有了，好，OK。right，现在就把这个发回给你。好，Aaron 来了是吧？OK，开一
I
下
didn't do
camera。
it. I didn't do any homework.
Yeah, that's fine. Okay. I believe you were pretty busy then.
I think so.
I
Yeah.
think so. Okay. Yeah, that's fine. Let's just turn on our cameras and let's do some questions together. Okay, so today I wanna yeah, there were a few chapter 15 and chapter 16 challenge problems, and also maybe we can do a few discriminant stuff. So today we'll just do some homework, okay? And yeah, just do just like practice. Jason 啊，你那个 conics，did you
嗯，
have you learned conics yet？
没有，下礼拜
还没有是吧
开始。
？OK，那我们就周二再说吧，conics。
行，
Yeah，Emily，你现在有没有什么学校数学的问题需要讲？
我学校数学第二个学期，
哦，行，好，那我们就直接看一下你的 Chapter 15啊。Let's see Emily's questions. Okay. Oh, last time we were doing this example problem. Okay, maybe we'll do it later. Let's just do 15 and go to 16. Let's do it one by one. 15.37. question is pretty straightforward. So if anyone has any idea, let me know. 这种题，Emily，我是觉得你应该能做出来的。你这个题不应该
我感觉我就是我带一个数进去的那种题都不是很会做。
啊，带一个这种 Pete 啥的是吧
嗯
？OK, that's fine. 看一下啊。So we're given an inequality, and we want to know basically the possible values of this, right? So obviously we're gonna first solve the inequality. I think there's no problem about that. Okay, so I'm gonna solve it. That makes sense? Jason, Aaron, yeah. Okay, let's solve this using factors, whatever. Let's say we use factors less than 0, 小于取中间，对吧？ Because the leading coefficient is positive. Opens upwards, 小于取中间啊。Okay, so the graph, Aaron, is like this, if you remember, using graphical method, okay? There were many methods that we have learned. You can test a point, you can test numbers, you can do a sign analysis, right? But for this class, okay, for me at least, I require you guys to use graphical method because that's the fastest, and that really shows how you understand graphs, okay? So you have 2, you have 3, opens upward like this, right? You want less than, so that's the bottom part, this part below the x-axis. Apparently the answer is between 2 and 3. Does it make sense? Okay, so in other words, this condition translates to this, right? So this is what we know for now. X is a number between 2 and 3. Well, doesn't that help us to find the possible values here, right? So what is our P? It's x squared plus 5x plus 6. Does anyone have any idea? Basically, when x is between 2 and 3, what are the possible values here? It's like domain and range thing, you see, right? It's like the domain is between 2 and 3. What is the range of this function? What do we do? No idea? Emily 没有想法吗？Jason
我嗯，
至少得有个 intuition 吧？
那
嗯，
他俩一个是 x 加2加x 加3，一个是减的。但
加减没关系。你看我们已经说了，第一个这个减你现在不用管它了，为什么？因为这个式子已经变成了这个条件了，看到没有？我们就用完了第一个条件了，放一边
嗯，
不要了，对不对？你理解意思吗？一个条件用完了，你目前得到一个结论了，感觉就是那个条件没啥用了，跟它
要把它带，
没有关系。对，就是现在是已知这个限制条件要求这个的值啊，
那你
是不是感觉直接一带就完了？
随便带一个，
对啊，对，随便带个2，带个3，对不对？
随
就最
便带一个就行了吗？
这当然不是那么简单，就是说至少我是意思是说 intuitive thoughts，至少 intuitively 你应该这么做，就是 intuitively 你明白吧？就是本能嘛，感觉应该这么做，right？这最
嗯，
起码的感觉，对吧？不要纠结于它是减5还是加5，它 doesn't matter，因为第一个它那个减5只是为了给到你这个 condition，没问题吧？OK，那么看我们想另外一个 case 啊，诶，where's Jason？OK，maybe he joins back later. All right, Aaron. So what I said to Emily is that Emily was focusing on this minus 5x plus 5x thing. Okay. I don't think that's something that should attract your attention because even though they look like this, they look the same, but it doesn't really affect how you do this question. This is a condition given and we translate into this, right? So basically now we know x is between 2 and 3. Okay, Emily? It doesn't really matter what function you are trying to get. Say that you just do x plus 1. Let me ask you, what is the possible values? What are all the possible values of x plus 1 here? Knowing that x is between 2 and 3, obviously if you add 1, it's just between 3 and 4. That's the answer, right? Emily 看有没有疑问？题目相当于是想要告诉你 x 的取值范围，根据 x 的范围呢，你去找它的这个后面这个 equation 的范围。这个 equation 其实是啥都可以啊，比如说 x 加1它可以，对不对？ Say another example is say 2 to the x. Okay, 2 to the power of x. What is the range here? Well, x is between 2 and 3. Obviously, it's between 2 squared and 2 cubed. So between 4 and 8. 对不对，Emily？所以它跟这个减5和加5 x 没有任何的关系啊，明白了吗？OK。Alright, Jason, you got disconnected.
嗯
Yeah, OK。我刚刚在这边刚刚稍微说了一下，看看你因为刚回来啊，因为刚刚 Emily 呢，老是去纠结说前面是减5x，后面是加5x的这个地方，他纠结它。OK，那么我刚刚讲的就是说你不需要去纠结，为什么呢？因为这个 condition 啊，so this condition translates to this, right? X is between 2 and 3. You just need to use this piece of information. You know that x is between 2 and 3, and then you use that to determine whatever, well, equation they have and whatever possible values it can be.
嗯哼
For example, say the equation is x plus 1. You know that x is between 2 and 3, then x plus 1 has to be between 2 and 4, 3 and 4, right? Say that the expression is 2 to the x, then if x is between 2 and 3, obviously we just, well, 2 to the x is between 4 and 8, right? Something like this, okay? Yeah. So the question is, yeah, what is the range of this given 2 to 3? Now, intuitively, we want to plug in 2 and 3, and obviously we think that maybe we plug in 2, get a smallest value. When we plug in 3, we get a largest value, right? But there might be a problem because this is a quadratic. So think about this. Think about a few different cases. In your mind, you should be able to think about this, okay? So this is a quadratic. Now, let's say 2 is here, 3 is here. Obviously, if x is restrained in this domain and you have such a quadratic, and that means the lowest value you can take is when x equals 2 here, right? We can say f of 2. And the maximum value you can take here is, okay, let's say this is a graph. But anyway, find the intersection, and that's f of 3. So it's between f of 2 and f of 3, right? Okay, guys, that makes sense? So you want to plug in 2 and 3. But this is only true when it's on, say, one side of the quadratic. There's the axis of symmetry, right? The axis of symmetry, and there's one side of a quadratic. What if this question doesn't look like this? What if it's like, say, like this, right? So this is 2, this is 3. If the quadratic is like this, when you find f of 2, you find here. When you find f of 3, you actually find here. So you might think, okay, it's between f of 2 and f of 3, but there is actually a vertex here that's actually lower than both f of 2 and f of 3. That's what you need to consider in this question, right? So basically in this question, you need to think whether 2 and 3 on the quadratic given, is it like 2 and 3 does 2 and 3 covers the vertex? That's something you need to think about, right? If it does cover the vertex, then that means the lowest value must be taken at the vertex, right? The lowest y. And the highest y is basically whatever whether f of 2 is higher or f of 3 is higher, that's the maximum. So the maximum is from the vertex to, that's the minimum. And the maximum is either f of 2 or f of 3, depending on which value is larger. See if that makes sense? If the given interval covers the vertex. I'm gonna give you guys just a few seconds to let it sink in, right? If the given interval covers the vertex, right? If the given interval, say, covers only the left-hand side, maybe this is a quadratic, that's the axis of symmetry, right? Say the given interval is actually here, like from here to here. And that means the largest value is this value, say a and b, right? The largest is f of a, the lowest is f of b. So if it is on the left part, okay? If the given interval only covers the right part, then of course the largest value is f of b, smallest value is f of a. Does it make sense? Yeah. So here you need to think if the given quadratic, I mean, if the if the given interval covers the vertex of the given quadratic. That's what you need to think, okay? And this actually brings us to some other ideas, which we will talk about later, okay? So let's think about this. How do we know this interval covers its vertex? Or even if you didn't think about all of those in this question, I mean, at least you should draw a graph and look at what happened, right? 是不是啊 Emily？最简单的方法，哪怕你刚刚啥都没想到，你最起码画个图，看看啥样吧，因为图并不难画，对不对，Jason？OK？ So let's give it a try. So we graph it. This is factorable. So that means we just get two x-intercepts, and then we just get a rough sketch, right? So this is x plus 2, x plus 3. So we graph this. The x-intercepts are -2, -3. So you see, I'm gonna leave some space on the left-hand side. So this is -2, this is -3. Basically, this is what a graph looks like, right? The given interval is from 2 to 3, which is here and here. Now we can imagine this goes up, right? Obviously, the lowest value is f of 2. The greatest value is f of 3. Correct, Aaron, Jason, Emily? Yeah. So given this interval 2 to 3, then we can know all the possible values. Basically, all the possible values here, let's say this p is f of x, and this p is just between f of 3 and f of 2. You just plug in, and that's it. That will be the answer. Okay, any question, Aaron, Jason? If it covers the vertex, right? Say that you draw the diagram, maybe you still say that it's the same diagram, okay? But the question actually changes to say -3 to 3. If that's the case, it's gonna go from -3 to 3. That means we are looking at this part of the graph from here to here, right? This entire graph. Obviously, the lowest the value is taken at a vertex. The highest value is taken at L of 3. So if the question is from -3 to 3, basically we just need to figure out this lowest value. The highest value is still f of 3, you see? And to figure out the lowest value, vertex formula. C minus, right? C minus 4 b squared over 4a, right? So this this lowest value will be 6 minus b squared over 4a. Basically this, which is -1/4. You see? It's going to be from -1/4 to f of 3. Okay, does it make sense, guys? Yeah. Okay, I believe this is one of the, I think it should probably be the first time you guys have ever seen this kind of question where an interval is given and you need to find a range of another function. But the method will be something that we mentioned last time when we talk about how to find domains and range, right? So domain is given. If you want to find a range, the easiest way is to graph it if the given equation is graphable. And in this case, it's pretty easy to graph it. So graph it and have a look, okay? Okay. To summarize what we just discussed here, I'm going to introduce some concepts today, which is really not on this book. It's on another book, okay? But I think everyone should know and you guys can fully understand. It's not hard at all. These concepts are not even in school curriculum, at least not in Canada, okay, Aaron? I'm not sure about US. No, I am pretty sure about US. In the States, they actually talk about it, okay? Because I have another student in Boston. She actually, her textbook went through all these concepts. Somehow Canada doesn't went through this, okay? Doesn't go through this. So let's have a look. What we just saw here was that if you're on the so-called right part of the graph, basically the whole graph is going up, right? It's been going up continuously, okay? If we're talking about the left-hand side, the whole graph is going down continuously, okay? But if we're talking about this interval, that the interval that covers the vertex, it goes down and then goes up. So this so-called go up and go down, we have terms for it, okay? If the graph is going up, something like this, okay? Then we say this function is an increasing function. an increasing function. What an increasing function, have you guys ever heard of this word? Increasing and decreasing function? No. Jason, Emily, no? Aaron? So Aaron, you are not at that level yet, I think. But Jason and Emily, if you guys are in the States, you will know this. And if you're in China, you will know this. This is like grade 8 in China too, okay? But it's very simple, okay? So to define it, what it means by going up, it basically means that when x increases, so we go from left to right, y increases, right? So x increases, y increases. Very simple. X increases, y increases. In other words, the independent variable in IV, independent variable increases, dependent variable increases. In terms of signs, I mean. Okay, in math, we just say x and y, input, output. In science, we say independent, dependent variable. I think you guys should have known this, right? This means you have a positive correlation, something like that, okay? On the other hand, if it goes down, say the graph is like this, then we say this is a decreasing function, which means that when x goes up, y goes down, right? So y goes up means that you go from left to right. You see that y goes down. You always go from left to right, okay? You always go from left to right when you look at a graph or a function, because the reason why we only look at x is because x is an independent variable. You vary x, right? And you output y. So we look at x. And we always go from left to right because that's the positive direction. Yeah, it literally has an arrow here, okay? Yeah, so x goes up, y goes down. That's decreasing function, okay? We can turn these ideas into mathematical equations and stuff because here we're not using proper notations, right? So to use proper notations, we say this. The definition of a increasing function. We say that if we have two x values, say the x2 is greater than x1, then f of 2 is greater than f of 1, f of x1. You see, very simple. The larger the x is, the larger the y is. That's it. That's the definition of an increasing function. On the other hand, for a decreasing function, we just say if x2 is less than x1, no, sorry. It's still greater than this, and f of x2 is less than. We basically just switch the direction here. This means the greater the x is, the smaller the y is, right? Okay, so increasing and decreasing function. If you guys are in China, you actually have to prove a function is increasing and decreasing. Not also in States, but in Canada, it's not required. It's not required in a math competition either. So I'm just gonna show a case to you guys, and you just need to know this, okay? You don't have to master how to do that, but Aaron, you might want to know, okay? So how do you show that a function is increasing or decreasing? Let's just say a very easy example, 2x minus 1, okay? Obviously, it is increasing because the slope is like going up, right? So obviously it's an increasing function, okay? So how do we show this? We take the definition. Always remember when we need to show something, we use the definition, okay? So in this case, we just say, let x2 greater than x1. If you let this, notice that you just need to show this, right? F of x2 is greater than f of x1. So that means you just do a subtraction, you will know, okay? In other words, if you do a subtraction, it should be greater than 0, right? So this is something you want to prove, okay? So how do we prove it? We just plug in and try. We get 2x1 minus 1, right? Minus bracket 2x1 minus 1. 2x2 minus 1 minus, right? Okay? Did that make sense? Open up brackets, you just get 2x2 minus 2x1. The ones canceled, which is 2 times x2 minus x1. Now, since we have this, x2 is greater than x1, this is greater than, right? So this whole thing greater than 0. We prove this. You see, we prove this. So we get that f of x2 is greater than f of x1. That's the proof. QED. Very simple. This is how we show or prove that a function is increasing or decreasing. That'll be the same. So whether increasing or decreasing, you always let this a number greater than another number, and just do a subtraction and see if the result is greater than or equal or less than. Okay. All right. Some more some more information about this. Okay, this information not again not covered in Canadian curriculum, which is really lacking in my personal opinion. Okay, should be that. Education should be like that. Okay, so let's see this. In this case, you couldn't say this is decreasing or increasing, right? Because the whole function is decreasing the beginning and then it turns into increasing. Okay, so but for something like this is always decreasing or this is always increasing. Okay, so for these functions, we call them monotonous functions.
We learned about increasing and decreasing functions at school.
You did? Okay, that's very
We're
good.
doing it right now. Like I'll be learning it tomorrow.
Okay, very nice. Very nice.
But
So
we did learn monotonous though. We just like identify the domain and range of when it is increasing or decreasing.
yeah,
I'm
very
not
good.
important.
It's called interval of increasing and decreasing.
Yeah,
Very good.
interval. Yeah, we learned
Yeah.
that. But probably in honors, you guys they learned about this.
Yeah, that's fine. I mean, I think maybe it's not a time. Maybe in the next book you would learn this. Okay, it's very simple. Okay, Aaron, for this, very simple. So, yeah, Aaron is in the United States, guys. So that's why he's learning this. So Emily, Jason, you don't get to learn this in Canada. Okay, but anyway, so if it's always decreasing or always increasing, we call them monotonous functions, and I think that should make sense, right? Monotone means 就是单调。对吧？单调就是说啥也没有嘛，很单调，right？就是中文就叫单调函数。Okay, so if it is increasing, we say it's monotonously increasing, monotonously increasing. Okay, or a monotonously decreasing functions，就是说单调，这个中文叫递增函数和单调递减函数。中文递增递减非常的 make sense 的吧？递增啊，逐渐增加；递减逐渐减少。单调递增就是永远在增加，单调递减就是永远在减少。Monotonously increasing function. Okay? Yeah. But most likely you don't get to see this. You only get to see something like quadratics or even like this, right? So if you have like, right? Then you have increasing, decreasing, increasing, decreasing, increasing functions. So you have a bunch of different stuff. Okay? So I'm just gonna show an example. Let's say we have this. Now, let's say this is A, this is B, this is C. Okay. So before A, which means when X is between negative infinity to A, that's the increasing part, right? Obviously. Between A and B, that's the decreasing part. Between B and that's the increasing part. After C, so C to infinity, that's the decreasing part. So Emily, Jason, that should make sense, right? So we call these intervals of increasing and decreasing. So even though the whole function is not always being increasing or decreasing, that's fine. We just say we have intervals of increasing and decreasing. In this case, the interval of increase is, say the interval of increase is between minus infinity to A and also from B to C. Okay, you can include the number or not, doesn't matter because, it really doesn't matter because it doesn't matter.
This came out as a debate. So
Yeah.
like the math teachers are debating like, can you actually be on a point? Because it's just a point and you can't include that. So we just put parentheses instead of the square brackets.
Yeah, anyway, it's actually you can include or you don't include it's fine because okay, what your teacher said is not accurate because think about this. Even if you include A, you just consider this part, it doesn't violate our definition. Think about this. It does not violate our definition because say that you take the value of A and you take a number less than A. Let's say here we have a number E. Instead of E, say that this E is less than A. from the graph, you can actually see that f of e is less than f of a, which does not violate the definition, see? So that means you can take the a, okay? I think maybe you misremember this. You couldn't take the a, maybe it's in another context, okay? In this case, you can actually take, say, b and c, and you take a, it doesn't matter, for interval of increasing and decreasing, okay?
Oh, I think maybe the problem included open circle. So
yeah,
so it kind of
maybe.
yeah.
Yeah. Okay, anyway. So I think this makes sense to Emily, Jason, right? So this is what why I'm talking about this. I'm trying to summarize what we saw here, okay? Which is basically that if you're given an interval, and if this interval only covers the increasing part of the function, which in other words, the given interval is within the interval of increasing. Then that means, well, f of 2 must be less than f of 3. And since it's increasing, so the range it will just be from f of 2 to f of 3, right? Obviously. Okay? If it is in the interval of decreasing, which is this case on the left-hand side, then that means the smaller number actually takes the bigger value. The larger number for x actually takes a smaller value. But the range is still between them. Okay? Since both parts are monotonous, right? So on the left-hand side is monotonously decreasing. On the right-hand side is monotonously increasing. If the interval is there, you know what to do. Okay? The most complex problem is something like this. So the interval covers, say, a lowest value or a maximum value. And that's then you need to determine that value, okay? And that will be something like this, right? So we have some more terms about these. Let's say this value. This value is what we call the local maximum. Now, Emily should know this. This is from AP Calculus, right? Local maximum, and that's another local maximum, see? Collectively, they're called local maxima. Okay, maxima is the plural form of maximum. Okay, not maximums, maxima. Okay, local maxima. And of course, here we have a local minimum. Okay? So you will see that when the interval given covers a local maximum or local minimum, then that means you need to figure out the maximum and the minimum to determine the range. Okay, and also reason why you call it local is because you're not sure if it is the maximum of the entire function. Let's see another example. Let's say we have a function that looks like, say, this. You see, local maximum, local maximum, local minimum, local minimum. But none of them is the actual maximum or minimum of the entire function, because the entire function is obviously from minus infinity to positive infinity. Okay? But if you do, say, this, in this case, there's no minimum because it goes to negative infinity, but it does have a maximum in this case, right? So this is not only the local maximum, it is also what we call the global or absolute. Sometimes we call it absolute. Absolute is more common, actually. Global is less common, but anyway, we call it the absolute or the global maximum because it's for the entire function. Just some words that I think I should know. Okay, and Jason, you will learn about these in AP Calculus anyway. Okay, yeah. Yeah, all right. So that's the idea. Okay. You guys have any more question for this kind of question? Because last time, I remembered you guys was struggling with domain and range, right? So this is another perfect example where you have a restricted domain and you're gonna find a range for that domain, for that specific domain, right? So you're gonna see if it is increasing or decreasing, or is it like both the increasing and decreasing? Okay, so you know what to do. Okay, if there's no more problem, I'm gonna continue, all right? Okay, 15.39. Does this expression have a minimum value? If so, find it, or if not, explain why it doesn't have a minimum or maximum value. Let's see if you guys have any idea. Emily 没做，对吧？那 Emily 没做的原因是啥？你觉得这道题它是怎么难住你了？
就是我就开始没有想出来怎么算那个 minimum value。
哦，OK，好，你都没有想出来，那这个式子找 minimum value 应该是非常熟悉的吧？我们目前已经，虽然里头的东西不太熟悉啊，但是整体的样子应该很熟悉啊。这是个什么样子？
这是个
这是 it's
Vertex form of a quadratic.
exactly vertex form, right? Emily, Jason, right?
哦，
Okay, this is very similar to what we learned. Something like x, say x minus 2 bracket square plus 10, right?
是的，
It's just that the the stuff in the bracket is different, but the logic should be the same. What is the logic of behind all of these completed square and vertex form? What is the basic logic? 是什么？所
我是
有的这些，嗯
The vertex is just the same HK.
HK, yeah, but what is the rationale for all of these? For completed square, for vertex form, for whatever? The basic knowledge, the basic logic is what? A number squared is
Must
greater
not
than
be it's not negative. It's not negative.
is non-negative, right? Emily, Jason, right? A number squared is non-negative. So from this expression, right away you can see that this part should be greater than or equal to 0. So plus 10, it should be greater than or equal to 10. So that means the minimum should be 10, right? But the problem is it really 10? Why am I asking this? Because inside the bracket, it's not like something, it's not just simply just an x or x minus 2. If it isn't an x or x minus 2, whatever, then that means you can, like, like the number inside the bracket can be whatever number you want, right? If that's the case, well, you can take it to 0, then the minimum is 10, right? In this case, you're not even sure if the bracket can be 0, right? Think about this. Maybe the number in the bracket can only be 1, for example. It couldn't be 0. Then that means your minimum value should be, well, greater than or equal to 1 plus 10. The minimum value would be 11. Right, Emily, Jason? Right? So intuitively, we are thinking about 10 because this is a number squared. And you have to remember this. I can't remember how many times I have stressed this, right? Emily, Jason, Aaron, right? I've stressed this many, many times. A number squared greater than or equal to 0, especially when you're trying to find a minimum and we will see this. You have to have this awareness, right? Okay, but to test if it can be 0, you just give it a test. If it is possible, so our question becomes, is it possible? Can whatever here be 0? If not, what is the minimum value of this, right? So how do we determine? Basically, we want to know the range of this, right? What can we do? This is a fraction, and you subtract an integer from it. How do you simplify this?
乘以 x 加1。
对, get a common denominator, right? This goes without saying. So, I mean, when you look at it, there's nothing you can think of or do other than getting a common denominator, right? So there's really nothing special about this. So you do a common denominator, okay? Whenever you have fraction, subtraction, or addition, you find a common denominator, okay? So what do we have? 5x minus 5x, x is gone. You have 2 minus 5 minus 3. So the answer is minus 3 over x plus 1, right? Can anyone tell me, can this equal to 0?
Oh, wait, why did you just move the 5 over and times x minus 1?
Getting a common denominator, right? The
Yeah,
denominator. Yeah.
but like why?
Why do we get a common denominator?
Yeah, like why if you want to simplify this equation, you can just move the 5 over.
Oh yeah, that's the same. Yeah, that's the same. I mean, if you move it over time by x plus 1,
X minus 1, yeah.
yeah, you get the same result.
Same result, right?
Yeah,
Yeah.
you do. So you can choose whatever, okay?
Isn't that kind of easier? Because you don't it doesn't involve like multiple.
Yeah, I mean, in this case, it would be easier to move the 5 over here and time x plus 1. In the end, you'll get basically the same thing. Okay, Emily, Jason. But Aaron, I do this because you don't always have an equation. Sometimes you just have an expression, okay? You don't have this equal to 0 thing. If you just work on this, you're gonna get a common denominator, right? Okay, so yeah, so that's why I'm talking about this. Yeah, so the idea is that you can always do common denominator. Sometimes you can do something else, but you can always do common denominator. Okay? So the question is, can this be 0 or can that be 5? That's the same, okay? Because for the other equation, if you do it, it will be 5x plus 2 equals to 5x plus 5. Is it possible? Obviously not. It's 2 equal 5, right? So not possible. If that's not possible, you go back, that's not possible, okay? But what about a common denominator thing? How do we know that this is impossible?
A constant divided by a variable number can never be 0.
Yeah, very good. Why?
Because you can't divide by 0.
Uh, to get a 0, do you need to divide it by 0? If you divide it by 0, you don't get 0. You get undefined or you get
Yeah.
infinity, right? How do you get
Um,
0 in a fraction?
when the numerator is 0 and
Very
0
good.
is not equal to -3, so it's
Very
not
good.
possible.
Very good. Exactly. Very good. Okay, Emily, Jason, right? So I think you guys should know this. When a fraction equals to 0, the only possibility is when, well, the numerator is 0. And meanwhile, you have to make sure the denominator is not 0, by the way, okay? So denominator is not 0, and the numerator is 0. In this case, the numerator couldn't be 0. The numerator is already -3. It couldn't be 0, okay? So this part couldn't be 0, then this entire thing couldn't be 0, then this couldn't be 0. Okay, make sense? So that means you couldn't take 0 here. Then if you ask, what is the minimum value? Well, does anyone know? What is the minimum value of this? -3 over x plus 1. Or simply just 1 over x plus 1, whatever. They're the same because compared to x plus 1, 1 over -3 constant doesn't really matter. What is the minimum value here? How do we get a minimum? Okay, goals and by the way, guys, in the future, I want to yeah, I just started doing this. Okay, you guys should know. I also study psychology, right? In psychology, we have what we say the means and analysis. Means and analysis. Okay, what this means is simply and means your goal, what you want. Okay, your end result, right? Means simply means ways. I think for math, this is very good. Okay, every time I want you guys to tell me what you want to do and how to do it. Okay? What you want to do and how to do it. What we want to do is to take a minimum value. And how? For this or for that, doesn't matter, okay? How do you minimize such a fraction? What did you learn about fraction that can help you minimize these? Notice that the numerator couldn't be changed, right? You can only alter your denominator. So how do you make it small?
The greater the denominator, the smaller the value.
Exactly, right? Emily, Jason, right? Yeah, the greater the denominator, the smaller the value. So how do you minimize this? You want to make your denominator the greatest you can, right? But is there a greatest value here?
I don't think so.
It's just linear, so it doesn't have a greatest value. Emily, just right? It can go to infinity. Infinity is not a number; it's a concept. Okay, and Aaron, you know this. And by the way, why is infinity not a number? Because if infinity is a number, then by definition it should be the largest number, right? There is no largest number in this world, because if you say there's a largest number, then let me ask you, what if I add 1 to it? It's a simple proof by contradiction, remember? Okay, so if there exists largest value, I add 1, I will get a even larger value, which proves that there's no biggest value in this world. So that means infinity is a concept, it's not a number. No number can equal to infinity. They can only approach infinity, okay? So in this case, we just write down that x plus 1, I want to maximize it. It just goes to infinity. It approaches infinity. When it approaches infinity, this fraction approaches what?
0.
0. Good, right? But it can never equal to 0. It can only approach to 0. Say this is a million. 1 out of a million is 0.000001, right? 1 out of, say, 10 billion is going to be 0.10 zeros, 1. It's very small, but still, you're not going to get 0. You're only to get approaching 0. Does that make sense? So what this means to us is that this whole expression cannot be 0, but it can be just a little bit greater than 0. Say 0.0000, just numerous 0 and 1, right? And that means if you add 10 to it, this whole thing is just greater than 10. But unfortunately, this doesn't allow us to have a minimum value. You cannot say the minimum is 10 because it couldn't be 10. But you couldn't say there is a minimum value because if you say there is a minimum value, what is that minimum value? That minimum value should be 10.001. And how many zeros are there? It should be infinity, right? Infinity zeros. So you couldn't say there's no such a number. Make sense? Okay, so that means in this question, there is no minimum value. All you know is that it's greater than 10. And it can take any value greater than 10. But the 10 itself couldn't be taken. So there's no minimum value. Does that make sense? 那我们还可以吧，对吧？就是没有那么难，对不对？对吧？就是还是这个一个东西 square 的呀，一定要想出来啊。
What if x plus 1 approaches negative infinity? Like you put negative numbers.
Negative numbers. Okay, 1 second. What did you say?
When x plus 1 approaches like negative infinity.
Oh, okay, yeah. Okay, yeah, we can talk about it. So Aaron asked, what if it's negative infinity? Now, the difference between infinity and negative infinity is just a sign, right? So if it is infinity, you get almost 0. Then if you add a negative sign, it's still almost 0, right? Okay, so think about, say, 1 divided by negative a billion, Aaron. That's just negative 0.000000001. So just a tiny little bit less than 0. Okay, so the difference it makes is that in the first scenario, this thing is a tiny little bit greater than 0, right, guys? And when this happens, this whole fraction is a tiny little bit less than 0. Okay, so what we can do is we can actually write down these. And this is way this is much beyond our curriculum. Okay, this is calculus already. So if x plus 1 is infinity, we say that this approaches 0. When it's minus infinity, it still approaches 0, right? But one is greater than 0, the other is less than 0. What do we do? What we do is that we put a plus and minus sign on the top right corner of the 0. You see? What this means is that in this case, okay, this fraction approaches 0 from the positive side, meaning that it's greater than 0, but almost 0. Okay, in our second condition, since the denominator is negative, this whole thing must be negative, right? But still it approaches 0. We say it approaches 0 from the negative side. In other words, it's less than 0, but almost 0. Okay, that's the difference. Okay, Aaron, you see, this is 0 point a bunch of 0, 1. This is minus 0 point a bunch of zeros, 1. Okay, but pay attention to the sign though. Say in the first example, it will be different. If the denominator is infinity, but since the numerator is actually a negative number, So in this case, we say this approaches 0 from the negative side. So the sign matters, okay? In the second example, when it is negative infinity, negative canceled out, you get positive, so it approaches from positive side, okay? Yeah. But Jason and Emily, you don't have to master these notations yet, okay? Just understand the idea behind it is fine, okay? The notations are for calculus. Which means calculus is actually much easier than math competition. Just a bunch of ideas. It's pretty simple, yeah, compared to these. Anyway, let's look at 15.40. Okay, Aaron, see if you have any more question before we move on.
No.
Okay, good. 40这道题应该是 Emily 应该得会做的。这道题真的就是我们讲过那个 discriminant 啊。OK，你可以看一下。If x is real and we have this thing, what is a complete set of x values for which y is real? What does it mean for which y is real? Emily，这道题你觉得什么意思？因为我觉得你没做出来，主要是不明白它的意思。我觉得明白了意思，这个方法是很简单的。
y
就是最后那个问题啊，它是啥意思呢？他说有什么 x，他让你找到所有的 x 值，可以使得 y 是个实数，是吧？y 是个 real number。那这句话我感觉可能会对你的理解有影响。它啥意思呢？换句话说，
就是算 x
算什么 x？这个 x 说白了是啥？其实都可以，对吧？但
是
关键他说要使得 y 是 real，这个 y 是 real 在这里它啥意思啊？
y 是
感觉你
那
convert 想不过来是不是？
是的
translate 不过来，我想看看别人会不会啊？我想问一下啊。So Jason, Aaron, any idea? What does it mean to this question? It looks weird. Like, why is it real? What does it mean? If you guys don't understand, I can give you a hint, okay? And this hint, guy, by the way, you should think of it by yourself, okay, Emily, too. Even if you don't understand what it means, you can try. Like when you see this, obviously, the answer is not all real numbers, right? If it asks in this way, that means only certain x values can give you real y, right? So you want to give it a try if you don't understand what it means. Let's say x equals to 0, x equals to 1, x equals to 2, or whatever, -1. Let's plug in and let's have a look what it means, right? So let's say x equals 0. Okay, we plug in, we get 4y squared plus 6 equals to 0. That's for this. I shouldn't write it here. Anyway, maybe I'm just gonna put it beside. Let's say, yeah, we don't need to try that many. Let's just say we try 2, okay? And in the second thing, we have 4ay squared plus this plus 7. Okay? We just try 2 cases. Let's have a look. Now, x is 0, we'll get this. X is 1, we'll get this. Let's see. If x is 0, is there a real y value? And how do we know?
There's no real y value
Very good. Why?
because you subtract both sides by 6 and you will take a square root and that will be imaginary.
Exactly. Emily, did you guys see? Right? When x is 0, obviously, there's no real solution for y. There's only imaginary solutions, which means, well, 0 wouldn't be the answer. Wouldn't be included in the final answer at least, right? Okay. What about the second example? Can y be real? And how do we know? Asking if y is real is basically to solve it, right? How do
I don't think it would be real.
so how do we know?
You can subtract both sides by 7 and 4y, and
Yeah,
you
you
will
can.
still,
Okay, you can do that, Aaron. But
Quadratic.
what?
Like just solve y using the quadratic formula.
Do you need to use the whole quadratic formula?
Discriminant.
Discriminant. Very good, right? Right? You don't need Jason, right? Yeah, the significance, sorry, the number of solutions is not dependent on the quadratic formula. It's dependent on the discriminant, right? It's dependent on that square root. So b squared minus 4ac. So if you try b squared, obviously it doesn't work. B squared is only 16. 4ac is 16 times 7, right? So no real y. So Emily, Jason, you see what it means? It's basically asking what values of x can make the resultant equation so that the discriminant is greater than or equal to 0. That's what it means. That's what it means for which y is real. Okay, so this is also like a go-to strategy whenever you don't understand a question. Okay, if you don't understand what the question means, you couldn't translate into something you know, you try some numbers especially in cases like these, right? Okay. In other words, how can you have real solutions here? Discriminant. So in this question, you just use discriminant, right? Discriminant. It's a quadratic is about y. So what is a discriminant here? Anyone? These are coefficients, right? This is a, this is b, this is c, correct? In terms of y. Okay,
B
so
squared minus 4ac.
Tell me. B squared is what?
16x squared minus 4 times x plus 6. So
Very
16
good.
times x plus 6. 16x plus 96.
Yes, very good. What is 96? Yeah. So this is a discriminant of this function about y, right? And as long as it's greater than or equal to 0, that will be it. That will give you solutions. Okay, so let's solve it quickly. Divided by 16, and we can make we can do a factoring. That's minus 3 plus 2, right? Minus 3 plus 2, yeah. Greater than, and the a is positive, so it opens upwards. Remember, 大于去两边, right? We take both sides. Remember, okay, 大于去两边. So it's going to be greater than or equal to 3 or less than or equal to minus 2. Graphical methods. 没问题吧? Graphical methods. 3 minus 2 open upwards 去两边. OK， 这样子最快啊。Emily、Jason 没问题吧？你看这多快啊，对不对？一定要这样想才快啊。Yeah, and this will be the answer. So we said 3 minus 2 or any number greater than those should work. So for example, let's try. If x equals to 3, what happens? Notice that when x equals to 3, discriminant is actually 0. So that means you should only have one solution, right? So you give it a try. You have 4y squared plus 12y plus 9 equals to 0. See, you do have one solution because it's a perfect square binomial. The only solution for y, minus 3 over 2. So you have a real value for y, and then everything should make sense, right? When x equals 2, discriminant is 0, you should only have one solution. Everything matches. If x is 4, you should have two solutions. Any question? Okay, use discriminant for more than one variables is something like the main idea I was doing the discriminant worksheet, right? So this is like an easier version of those questions. Okay, we do have a few more, but I'm gonna leave some time for functions. And by the way, I found a mistake I did here. Okay. So if you guys, and since we're just talking about discriminant, let's have a look again. In the first question, you guys remember the difference of cubes is 1. We want to find the range of the difference of a and b. We're supposed to be x. And we somehow get an equation that has x and has b in it, right? And we do a discriminant thing because again, because of this, a and b are real numbers. So you think about this. In this question, when a and b are real numbers, it simply means that there were real solutions. So it simply means that the discriminant has to be greater than or equal to 0. Just like the last question, see? 所以这个也是你们要记住的。如果题目说 怎么样可以 for which 是谁是 real number？它其实意思就是说它有 solution。那有 solution 呢，基本都是跟这个 quadratic discriminant 有关啊。所以一个题看起来好像跟 quadratic 一点关系都没有啊，它很有可能。但是它只要 mention 了说有 solution，很多时候它不会说有 solution 啊，它不会说哦，for which value of x will there be a real solution of a number？它不会这么说，它只会说 for which value of x is y real？它会这么说。那他一说 real，你就知道它就是指 solution。只要他提到有 solution，就像这种啊，有 real number 满足一个事情啊，你到时候你看英文 satisfy equation real numbers whatever it means that there were real solutions and that means you should think about the discriminant because basically within high school curriculum the discriminant tells you the number of solutions. Okay, there's nothing else that can tell you the number of solutions. 所以一看到这种 real number 的题，就一定是跟 discriminant 有关。可以说，你的目标呢，就是要 establish 一个 equation，然后你可以用 discriminant，就知道它用 discriminant。这道题说后来我计算错，我后来才看到啊，这里是 4x，就我底下写了个1，所以这里也改成个4啊，写错了。这样子的话呢，答案这个应该是cube root of 4。Okay, so the answer is actually from 0 to cube root of 4。这是之前做的时候是个数写错了啊，顺便看一下。好，我们抓紧时间看一下 Chapter 16啊，如果时间还可以讲到 discriminant。Chapter 16，我看16，啊，刚刚 Jason 的题是不是有一个是错的呀？对，1.3的 D，1.3的 D。Oh, this. Yeah, Jason. Can you try to do this again? The range of G. You said all real numbers, but the range is basically what number you can get for y, right? For your g of x. So you notice that, say g of 2 is 3, g of minus 7 is 3, right? Jason, any idea?
Range is 3.
Yeah, the range is only 3, right? No matter what x you have, you can only get 3. In other words, this is just a horizontal line. Basically, it's just going to be y equals 3, right? So it's a horizontal line like this. So remember that how we say range? You squeeze it onto the y-axis, you can only find 3. For any other y value, the function is undefined. Okay, 没问题吧？ Okay, some harder questions. Chapter 16. 那个我看啊，16.49。OK，Emily 是不知道 commutative 是吧？你如果不知道啥意思的话呢，它这后面有解释的呀。你要读后面那个 an operation is commutative if 还有讲啊，reversing any two inputs into the operation does not change the output of the operation, no matter what the two inputs are。我都告诉你哇，你要去读的。
突然看了一下，我还是没有理解那是个什
哦，
么。
还是没有啊？那你觉得这个英语的语法是哪里阻止了你去理解它？
就是我后面看那个题和
啊，
这个玩意合了一下，没有怎么懂。
好，commutative 什么意思啊？Who knows? I think
就
Aaron should know. Emily, OK，那 Emily 说就啥？中文叫啥？Jason, do you know? Commutative, no? 这个其实小学的东西啊，elementary school stuff，OK，叫做交换律，很简单。加法乘法的交换律叫做加法呢，你 a 加 b 就是 b 加 a，乘法呢 a 乘 b 就是 b 乘 a，这就是 commutative。你看后面讲的事情不就这个意思吗？你看他说一个 operation 是 commutative，什么是 operation？就是算法，加减乘除都属于 operation。
我
OK，
好没错的。
对啊，你看他说 reverse 嘛，把两个 inputs 一换，does not change the output，不影响结果，不管这两个 inputs 是啥，这是他说的意思。不管你啥数，你换一下，并不影响结果，这就叫 commutative。你看底下专门给的例子呢，比如说 we have seen that addition and multiplication are commutative。你看，因为 addition 换数字，multiplication 换顺序，不影响，就这个意思好吧？所以这道题就是问 那这道题太简单了，你看，比如说 x 星号 y 和 y 星号 x 有区别吗？那没有啊，对不对？那么因为你 y 星号 x 的话，你就把它顺序换一下嘛，你这里换成 y，这里换成 x，把这个换成 y 方，把这换成 x 方，那很明显相等，所以它是 commutative 的，对吧？就这个意思啊。Okay, and the question B say this x, y. If you change to y this x, it becomes y squared minus x squared, obviously, right? And they are not equal. So that means question B is not commutative. Okay, that's what it means, yeah. Okay, anyway, this is not a hard question and you don't actually see this in competition. Okay, this is more like in SACT and stuff. Okay, SACT will test this. So I'm going to skip this. And let's talk about, say, 16.50. So Emily, 你这道题也没做，这道题我觉得也不难，对吧？因为上节课我们专门讲这个东西啊。那看看大家有什么想法，包括你为啥没做？
但是我没有懂它那个 have an inverse，
那上节课我们专门讲 inverse function 吗？
就是
它有没有它这个问题就是它有没有 inverse？那有 inverse 的条件是什么？上节课讲的
1-to-1 function.
one-to-one function horizontal line test, right? So can a quadratic pass the horizontal line test?
No, so therefore there's no inverse.
No. Very good, Jason, right? Remember? Yeah. So quadratic is like this. It cannot pass the horizontal line test. The only way to make it to have an inverse is to restrict domains. Remember? You have to restrict the domain, but it doesn't say you can restrict domain here, so nothing. Okay?
Is
Yeah.
it because you take a y value and you can get two corresponding x values?
Exactly. And that's true for every quadratic, right? For every quadratic, for most given y values, you can find two x values. Because it's symmetrical, you have like two arms, right? And that's the reason, that's the rationale for a horizontal line test. Okay, good. 16.51. 哦，这个题 Emily 你是觉得会做是吧？我看你没有标，没有标我就不看了啊。那么 Jason, Aaron, you guys can try. Basically, just try this and see what happens. Okay, give it a try. Emily 你也没试试，你要试试啊，看看是不是真的会。OK，知道你时间不太够啊，我们来讲这些带星号的难题。哦，还有上节课那道题，对，那我们先把这题讲完，我们再去回去上节课那道题还没讲完，让你们试一下，没试对吧？Okay, so f is a function having the property f of x plus 1 equals f of x plus f of x minus 1 for every integer x. If f of 1 f of 4 is 1, compute f of 10. Idea, 我现在说 idea. No one? 有没有 idea 我就给个 hint, okay? For this kind of question, you do know this relation is given, right? And it's true for every integer x. So that means if x is an integer, this is always true, right? And since you know f of 1 and f of 4, what can you do to this so that you can make them appear, right? Because you know 1 and 4. What can you do to this equation so that you can see f of 1 or f of 4 in it? And that's like an opener, right? A bottle opener to open this question, right? What can we do? Anyone? 这叫赋值法吗？就是 let x be a number because x can be any integer. So let x be any number. This would be true. And you would be able to generate a lot of equations from that, right? So say x can be one number so that you can have f of 1. Just let it be a number. Anyone?
Two.
2. Yeah, we can give it a try. Yeah. So if x is 2, because we see x minus 1, right? This will give you f of 1. Right, Emily, Jason? Let x be 2. this is 1, this is 2, this is 3. Looks pretty good because we know 1 and 4. We do want to go up, right? Notice that you can also let x be 1, for example. And that means the 1 will be here. But that will give you 0 and 2. We don't really want to go 0 because obviously we want to go from 1 to 4 to 10, right? In this question, you want to go up rather than go down. Okay? You can also let x be 0, for example, but there will be 1 and 0 and minus 1. It will be good if we are looking for, say, minus 10. If we know minus 4, maybe we do that way, right? Okay? But obviously, we try all of these. Maybe it works, maybe it doesn't, but you go with the most possible try, right? The try that, yeah, it seems the most promising. So let's give it a try. We have f of 3 equals to f of 2 plus f of 1. F of 1 is known, it's 1. Okay, very good. But we haven't used f of 4 yet, and we don't see anything from here, right? So how do we use that f of 4? What value can you make x to be so that you have f of 4? And there were 3 possible values, right? To get f of 4.
3.
3.
X is
Good.
3.
Good. Very nice. So Jason Emily, 你们觉得这个 3 make sense 吗？对不对？你们想啊 So if x is 3, you get a 4 here, you get a 3 here, you get a 2 here. That's really, really good. Because we are still seeing f of 2 and f of 3, the 2 unknowns, and we have f of 4. If you do say, if you let x be 5, for example, then this is 4, this is 5, this is 6. Yes, we are going up, but now we see f of 5 and f of 6, another 2, well, 2 more unknown numbers. So that means it doesn't really help if you do this, right? You see? It's not helpful, okay? But if you get f of 2 and f of 3 again, that's like a linear system where you can solve, or which you can solve, right? So like this, okay? So if you let x be 3, we get f of 4, which is 1. So f of 4, which is 1, and that equals to f of 3 plus f of 2. Do you guys see that? So with these two equations, I'm gonna put this here.
Is f of 2 1/2?
Is it? How do we solve for f of 2 and f of 3?
Substitution.
Yeah, substitution, elimination, doesn't matter. You can do whatever, right? Emily, Jason, right? You see, this is a linear system. If you think say f of 2 is a number, let's say this is A, let's say this is A, let's say this is B, linear system. So you can solve for f of 4, f of 3 and f of 2. Okay, so let's try to solve it. Yeah, we can do a substitution. So 1 equals f of 3. F of 3 is f of 2 plus 1 plus f of 2. And this simply tells you this 0, right? 1 cancel out, it gets 0. If f of 2 is 0, f of 3 is 0 plus 1, 1. So this is 0, this is 1, this is 0, this is 1. See? Everything makes sense. Okay? Yeah. So what do we do next? Now that we know 1, 2, 3, 4, we want to get to 10, right? What do we do? This should already inform you what we need to do, right? Basically, you just increase the value of x, and hopefully we can get some other linear systems, right? Okay, so we just give it a try. Maybe we'll try x equals 4 and see what happens, right? X equals 4, we have f of 5 equals to f of 4 plus f of 3. Oh, that's really nice. I like it because f of 4 is known, 1. F of 3 is known, 1. That's 2. And you just keep doing this, right? Because from this relationship, you can see that basically it's f of a number plus f of a number that's greater than by 1, right, or larger than by 1, right? And you get another number, right? So obviously, say f of 6 is just f of 5 plus f of 4, which is 2 plus 1, that's 3. And f of 7 is f of 6 plus f of 5, which is 3 plus 2, which is 5, you see? So it actually turns into a Fibonacci sequence, right? 看到没有？是不是这样？因为你说白了，每一个 f of 一个数就是前两个数之和嘛，说白了这道题对吧？前两个数这个 f 的和，那说白一直加呗。那说白这边有1和1，那之后你看从 f of 5开始啊，它就是1嘛。f of 6呢，它是2嘛，前面的 f of 4也是1，对吧？说白了，两个一加就是下一个，1加1是2，1加2是3，2加3是5，3加5是8，5加8是13，13加8 21。比如说，那这个是 f of 7，f of 8，f of 9，f of 10，那 f of 10就是这个13，对吧？嗯，OK。那么 Jason Emily 这个东西叫什么？这个就是1加1是2，然后1加2是3，每次相加得到下一个数，这是一个叫做什么数列呢？刚刚我也说了，Fibonacci，你听过吗？费波那契数列啊，Fibonacci 啊，Fibonacci，Emily 你知道吗？不知道是吧？我们写一下 Fibonacci，这个呢很有名嘛，对不对？
The
但是
golden ratio is related to this.
Yeah，very good，yes，Fibonacci sequence，OK。The Fibonacci sequence is defined to be so. F of 0 is 0, f sub 1 is 1, f sub 2 is 1, okay, 0 plus 1, and f sub 3, sorry, is sub, okay, f sub 3 is 2, and blah, 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 okay. The general rule is that f of n is f of n minus 1 plus f sub n minus 2. It has the so-called golden ratio, by the way. So Emily Jason 听过吗？黄金比例0.618或者是1.618都可以。黄金比例你听过吧？说一个长方形长宽比多少最好看呀？要是0.618或者说1.618是一个意思，就是说你的因为宽比长要窄嘛，宽比长应该是0.618是最好的。那长比宽呢，得是1.618，就这个意思。这就是黄金比例啊，这个1.618就是 golden ratio，或者0.618都是 ratio 一样的嘛，只是 take a reciprocal。这个 ratio 怎么来的呢？跟 Fibonacci 有关。刚刚 Aaron 说的对啊，也就是说，他找的是什么？他找的是这个。在这个 Fibonacci 的 sequence 中啊，如果我们到了非常非常大的数字，就到了很后面，这些数 actually 有比例了，会出现比例，它会变成等比数列，而这个比例呢就是 golden ratio，golden ratio 写成这样，也就是1.618。但其实它是1.618多少多少，它是个 irrational number，真正 number 是1加根号5除2啊，就是这个数。如果没记错的话，应该是这个数，还是根号5减1除2。嗯，让我拿这边去敲一下，是根号5加1，根号5减1，我有点忘了，我看一眼。哟，哎，对对对，就是这个1加根号5除2，大家可以算一下1.618。OK，so Aaron，I'm not sure if you understand, but
Yeah, but
yeah,
then
OK。
how come when I learned it, it was like you take two numbers, like f sub 2 is 1, f sub 3 is 2, and you add those two and divide by f sub 2. Like 1 plus 2 divided by 1.
1 plus 2 divided by 1. Okay. So
Is that right?
no, I don't know what you mean map of 2 plus f of 3 divided by f
No, no,
of
no.
2.
F sub 2 is 1, right? And f sub 3 is 2. And then
Mhm.
when I learned this, they said the golden ratio is just 1 plus 2, which and divide by 1, which is in this case. Like f sub 2.
But 1 plus 2 divided by 1 is 3.
Oh, okay.
Yeah. Okay. Oh yeah, basically when n gets very large, say like 1,000 or maybe the 10,000th Fibonacci number, and then by then you will see that the number actually become geometric sequence. Yeah. Okay. Anyway, there's something else. Okay. To prove this is actually pretty hard. Okay. That will be like in AMC12, like way later. Okay. So yeah. Just by the way, just think you guys should know this. Okay. Uh, where are we? So level 5 is 2, 1, 1, 2, 3, 5, 8. Yeah, still thinking. Okay. Yeah, we'll finish this. Yes. Next. 这一类题啊，你都可以看到，基本上是这样子的一个形式呢。 这道题是这样的形式。这种题呢，在 AMC12几乎每年都考啊，每年都要考这样的类型的题。这一定要这个 notation 呢，得了解看这种题怎么做。Okay, so this question is very similar to last question. You're still given this sort of things, and you're given some values. You're looking for another value. You see, okay, very similar. So for these kind of questions, you always do the same thing，叫做赋值法，就是给 x 一个值，试一下，看能不能试出来一些东西。Okay, so let's give it a try. Now, of course, you don't blindly assign some numbers. Oh, by the way, 赋值法就是说 assign numbers. Okay, assign some numbers to x and y. You don't randomly or blindly assign them. Of course, you're gonna observe first, right? You observe what you're given, you observe the form, you observe what you want, and then you try to make an educated guess what x and y can be. 没问题吧？数学中叫做 make 一个 educated guess，不是说受教育的 guess，而是说是个有根据、有想法，根据你的一些观察的一个 guess，不能乱 guess，对吧？那我们来试一下啊，大家可以观察一下，这个题很简单，非常 straightforward 啊，看看我们可以把 x 跟 y 取多少。这是式子 ，right? And you're given f of 500. You want to get f of 600, and you observe everything, and tell me what should x be and what should y be. 有 any idea? Yeah? Anything? 还没有什么 idea 吗？这个应该挺明显的，我个人感觉蛮明显的。Okay, I'm gonna give some hints then. So this is a functional notation. At 500, 600, they're within the brackets, right? Where do you see function notation here? Only two parts, right? Either here or here. So that means if you wanna assign numbers, either you assign this 500, 600 to this or to that, right? So do you want to assign on the top or assign here? Let's think. So okay, yeah, top, let's give it a try, right? If you assign it here, x is 500. X is 500. Here you have a y. What's next? What is y? 1? If y is 1, does it help? You just get f of 500 equals to f of 500. It doesn't help, right? If say f is 2, y is 2, you get f of 1000. Yeah, you can't get the value of f of 1000, but that's not what you want, right? 500, 500. What you want is 600. So what can y be? You want 600, not 500. What can y be? How do you
6 over 5.
6 over 5? There we go. Done. You see? 500, no one. Y is 6 over 5. No. So it's basically just 3 divided by that. This question is solved. You see? 看到没有 Emily, Jason, right? So we just try. So Aaron said we can try on top. Yeah, we can try on top. If x is 500, what we get 500y equals to f of 500 is 3 divided by y. We want to know f of 600. Obviously, 5y just 6 out of 5. This is a way to get, well, f of 600. 3 divided by that, so it becomes 3 times 5 out of 6. 5 out of 2. 简单吧？ And actually, we'll see that you can get to any value you want. Say you want to get f of 1. Now, basically, just make y 1 out of 500, right? You get 1,500. You see? Because you have 500y, you can manipulate it into any number you want. 容易吧，对不对? Okay? And I'm gonna tell you that you can actually make this part 500. And you can solve it too. And to do that, the greatest common factor here is 100. Because you see multiplication here, right? You should think about greatest common factor. So you can make, say, x equals to 100 and y equals to 5, for example. And that will give you 500 equals to 100 divided by 5. 500 is actually 3, right? In this case, you can figure out that f of 100 is actually 15. And then you make y equals to 6 and do that. You see? So f of 600, y is 6. And that's f of 100, which is 15, divided by y, which is 6. So 15 divided by 6, 5 out of 2. See? Same answer. So in this question, you can make this part or this part be 500 and 600 and figure out the other value. You can work it out. So you are many ways. OK 吧 ？OK。那么 Emily、Jason 可以试一下，这叫赋值法。这种题太常见了，在 AMC，尤其是 AMC 啊里面在这个加拿大竞赛也很多，好吧？就是他告诉你个这样的东西，就告诉你只有一个值，你就代值，想办法代数，带着带着就带出来了。其实这种题做起来还挺好玩的感觉，因为你带着带着带出来，蛮有意思的啊。Okay, Aaron, very good. Okay, Aaron, you see, the spirit is all about trying, right? You don't know, so you're gonna try, and then you will know. Okay, all right. Okay, that'll be all for today, and I will see you guys next week. Okay, homework again. Keep doing your chapter 16, Emily, Jason. Okay, finish your just try more. Okay, Emily 你多做一点啊。So next Tuesday we will talk about yeah, next chapter. Okay. Okay, that'll be all. Bye bye.